Uh-oh. Hey, y'all. My document camera. Okay. Uh-oh. This box is kind of in the way. Let me make this box smaller. There. Okay. Well, that's as good as it's going to get right now. And this is in my way. There. Okay. I think I'm set. Uh-oh, it keeps focusing. Let me change my focus real quick. I know how to change it. Okay. It shouldn't focus anymore. Thank you for being patient. Now, today's lesson is about dividing with exponent properties. We've already done multiplying with exponent properties, so now we're going to divide, and you may already kind of have an idea of what's going to happen. So for this first problem, we're just going to write it out, and I'm going to show you. 6 to the 12th means 6 times itself 12 times. I don't even know if I have enough room. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 6 to the 4th would be 6 times itself 4 times. And we can now divide. 6 divided by 6 is 1. And so we can divide out 4 sets of 6s. And then these are all the ones we have left. And so if we were to count these, 1, 2, 3, 4, 5, 6, 7, 8, we have 8 6s left. So 6 to the 8th power. And hopefully you see the pattern. 6 to the 12th divided by 6 to the 4th is 6 to the 8th. And I'm hoping little light bulbs are going off. You're going, oh, you subtract, which is correct. So our key concept, if you have a to the m and a to the n, notice my bases are the same. Uh-oh. Someone's calling me. Can y'all hear it vibrating? Oh, it's my brother. I'm going to tell him. Well, I'll call him back. Uh-oh. Come in. Hold on. Hey. Well, I'm recording. You can come in. No, don't say. You want me to come find you? You can come in, or I can come find you.
Are you finished, or you got a few minutes?
Oh, I just started.
Oh, sorry.
It's okay. Do you want me to come find you, or are you staying? Yeah. All right, so your bases have to be the same, and a cannot be 0. So we're talking about an integer, positive or negative, but your bases stay the same, and you subtract your exponents, m minus n. It's always the top minus the bottom. So 12 minus 4 is 8. So let's do some examples together. X to the 12th over x to the 7th. So again, my bases are the same, so I can subtract 12 minus 7. That's 5. So my answer is x to the 5th. And yes, it's that simple right now. Letter B, my 9s, the bases are the same, so I'm going to subtract 7 minus negative 3. And yes, minus negative is going to be plus the positive, so 9 to the 10th power. I do not expect you to calculate 9 to the 10th power. We're just going to write it as a power. Now, letter C has y, and y. So we've got several things going on. First, we need to simplify our top, our numerator. And this has an exponent of 1. Remember, if you don't see an exponent, it has an exponent of 1. And we add because this is multiplication. So 4 plus 1 is 5. So this is really y to the 5th divided by y to the 3rd. Now I can use my division properties, and I can subtract 5 minus 3. And so my final answer is y squared. All right, you try example D. Press pause and then play when you're ready. So I'm going to add at the numerator, and I get q to the 8 over q to the 4th. And then I'm going to subtract because it's division, and I get q to the 4th power. So that should be your answer. All right, example 2 says simplify the expression. So just some more examples. Now, you notice I have 2 variables going on. And like I said up top, the bases have to be the same in order to apply your exponent properties. So my x, I have an x in the numerator, but I don't have any x's in the denominator. So my x is just going to stay the same. I'm going to focus on my y's. Because my bases are the same, I can subtract 4 minus negative 3, and that is 7. So I'm going to bring my x down and y to the 7th power. So you just bring your x down. If you don't have anything, you can simplify with it. B, I have an a squared, b to the 8, and a on the denominator. Again, we're going to put a 1. And in this problem, I'm going to only be able to simplify my a's. I'm going to subtract 2 minus 1. So a to the 1st, a to the 1, which is just a. And then I'm going to bring my B down. All right, you trust C, press pause, and you trust C when you're ready. All right, so I'm going to put an exponent of 1 with my F, and I'm going to simplify my F's. So 3 minus 1 is 2. And then I'm going to simplify my G's. 4 minus 2 is 2. So your answer should be F squared, G squared. All right, example 3, simplify when you have coefficients. Coefficients are the whole numbers in front. And this is where some people might want to say, okay, 8 to the 5th power. But the 5th power is only with the x. The x is your base. The 8 and 4 are not bases. So what you do with the 8 and 4 is you just simplify or you reduce those like normal. So I'm going to simplify 8 over 4, which is 2. So I'm going to start with a 2. Now, because these are my exponents, I can subtract 5 minus 2, and I get 3. So x to the 3rd power. Again, your x's are staying the same, x, x, x. Your x's are not going anywhere. But your 8 divided by 4, you're actually reducing or simplifying that. So part B, let's talk about our coefficients. 2 over 8, we can reduce that to 1/4. So I know I'm going to start my answer with 1/4. Now I'm going to look at my x's. I have a 4 minus negative 7, which is actually 11. So x to the 11th power, that's going to go in the numerator. And now I'm going to subtract my y exponents, negative 3 minus negative 4. And that is a positive 1, so y to the 1st. Now, I really don't need this one coefficient, so this would be the best answer instead of having that 1 there because it means the same thing. All right, C, we're going to take our coefficients, and simplify our coefficients, and we get 3 wholes, 6 over 2. And then I'm going to subtract my exponents. 7 minus negative 3 is 10. So 3x to the 10th power. All right, so our last example says find the missing exponent. You see the question mark. We need to figure out what this missing exponent is. Well, I have division, and we know that when we have a division problem, if the bases are the same, we're going to subtract our exponents. 4 minus question mark, and that has to equal 2. Because everywhere else, when we subtracted, that answer became our exponent. So it's kind of like we have an equation. 4 minus x equals 2. We're going to subtract 4 on both sides, and we get negative x equals negative 2. Divide both sides by negative 1, and x equals 2. Whoops. So my missing exponent, question mark, equals 2. 4 minus 2 is 2. So example B, we start with question mark, minus 9 is 2, again. In this problem, I'm going to add 9 to both sides, and the question mark is 11. And then you can always go back and check your work by plugging it back in. 11 minus 9, does that equal 2? And yes, that is correct. All right, you try C, pause it, and then press play when you're ready to see the answer. So 15 minus question mark equals, what exponent did you get right here? I hope you had a 1. And then we're going to subtract 15 from both sides. And divide by negative 1, and your question mark is 14. If you want to check, you plug 14 back in, so 15 minus 14 equals 1, and yes, that checks out. All right. We will practice more of this in class.